All right, guys, we're going to start looking at inverse trig functions. We're going to switch gears from the graphing. We're done with that. Thankfully, it was a long time doing that. We're still going to continue to look at trig. And this is kind of a tricky topic, so we're going to go slow. We're going to kind of do this in two parts. Today, we're just going to look at the inverse sine function itself and kind of learn kind of what it's all about. And then we'll slowly move on to how to find some values and then the other inverse trig functions as well. Okay, so let me ask you the question. In the question here, it says solve the following for x. It says sine of x, and we know x represents an angle, equals 1/2. Normally, right? So normally what we've seen so far, right? Normally you might get something like sine of, pi over 6. And you have to give me the ratio, which you would hopefully say is 1/2. Now it's saying where basically is sine of x equal to 1/2. So you might say, oh, well, clearly one of them is pi over 6. That's the angle in quadrant 1. What's the angle in quadrant 2? 5 pi over 6, right? So in this problem, we solve for the angle measure. We didn't solve for the ratio, we solved for the angle measure of the trig function, where previously we're solving for the value or the ratio, right? Now you might be saying, well, Mr. Bonner, those aren't the only ones that we can find. We could keep going around the circle. There's really an infinite amount of answers, and technically you are correct. For now, we'll just give 2 of them, and then you'll kind of see how this is going to take shape, okay? So looking down here at the second paragraph, it says to solve problems where we're looking to solve for an angle measure in radians or in degrees, we use what is called an inverse trig function. Now that inverse is a key word. We're going to come back to inverse if you remember what an inverse is. So they're called inverse trig functions. It's also called sometimes an arc trig function. Okay, they just mean the same thing. It's an arc function or an inverse. Typically I'll use inverse, but you might see arc sometimes too. Okay, so basically in an inverse trig function, your input, right, let me write this, your input is a ratio, and your answer is an angle. That's the reverse of what, change colors, of this guy up here. My input there is an angle measurement, and my answer is a ratio. So they switch, right? Inverse is a swapping of inputs and outputs. We're swapping our inputs and outputs here, hence why it's called an inverse trig function. So let's just take a look at a few examples here. So it says solve the following inverse sine functions in radians for reasons that will become clear later on. Your answers and your angles, right, should range from negative pi over 2 to pi over 2. And I encourage you to pause the video and see if you can give me the angle measurements between negative pi over 2 and pi over 2 where these things would be true. All right, so for inverse sine of negative 1/2, it's saying where is sine equal to negative 1/2, okay? From negative pi over 2 to pi over 2, that answer would be negative pi over 6, right? You might say, well, Mr. Botter, isn't 11 pi over 6 an answer? It is an answer, but it's not following within the range here that I asked for of negative pi over 2 to pi over 2, okay? So I'm only looking for answers that are in the range negative pi over 2 to pi over 2. Inverse sine of root 3 over 2. That would be pi over 3. That is also within the range. And then arc sine of 1. Again, remember, arc sine just means the same thing as inverse sine. So it's the same thing as inverse sine of 1, right? That's another way to ask it. You should be familiar with both and understand that both mean the same thing. So where is sine equal to 1? Well, sine is equal to 1 at pi over 2. All right, so those are some of your basic inverse sine questions that you could see, okay? So you might be saying, right, why did my answers have to be between negative pi over 2 and pi over 2? I think the easiest answer for this lies in the graph actually of sine of x itself. So let's maybe look at the inverse trig functions and their graphs and the sine of x and its graph and how they might all be related, and that might help clear up why some of this stuff is true. Okay, so it says the graph of sine of x is shown below, so that should be pretty familiar to you guys. The question I pose to you is, would the inverse of this function, inverse sine of x, be a function itself? Now, if you remember back to your function days, right, there was something called the vertical line test, right? And if your function passed the vertical line test, or the VLT, that meant it is a function. So let's take a look at sine of x, okay? Does it pass the vertical line test? If I draw a vertical line through the graph of sine of x, at any point does it hit the graph twice? It does not, which means it passes the vertical line test, which means it is a function. Let me erase that. Okay. So sine of x clearly is a function. Is the inverse to that, is inverse sine of x a function? Well, you might remember that there was something called the horizontal line test, right? The HLT. What the HLT would say, right, is answer is the inverse to the function a function, right? So that's what the horizontal line test would test. If it passed the vertical line test, that means that the inverse to the function is a function. So if I draw some horizontal lines through the graph of sine of x, does it intersect the graph of sine of x more than once? Yes, it does. It clearly does. If I look at the top line here, it intersects here, here, right? And since this graph keeps on going up and down, it's going to intersect really an infinite amount of points, right? So that is really slow. So clearly this is not going to pass the horizontal line test. So would the inverse of this function, inverse sine of x, be a function? No, it would not, right? And it would actually look something like, it would look like something like, let's see if I can do this right. Almost kind of like this snake, almost like a vertical like sine graph, right? Now that would not pass the vertical line test, hence it would not be a function, right? Now think about that. Why are things that are not functions troublesome? Well, if I look at the graph here, well, if I look at this graph here, right, and I said, hey, what's inverse sine of 1, right? You would actually have an infinite amount of answers, right? You could have a point here, 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 right, that all have x values of 1, but there's really an infinite amount of y values that would correspond with an x value of 1. That would be chaos, right? It would be chaos. So what some really smart mathematicians did, much smarter than myself, they said, all right, well, what can we do? Is there anything we could do to the graph of sine of x such that its inverse would become a function? And what they said was, we're just going to actually restrict the domain of sine of x. We're going to make it such that we're going to restrict the domain such that we're only going to look at the piece from negative pi over 2 to pi over 2, right? Only going to look at negative pi over 2 to pi over 2, okay? And if I restrict the domain of sine of x to that, its inverse would then become a function. That's kind of one of the neat things. So what can we do to sine of x is restrict its domain. Let me write this out. Restrict its domain to negative pi over 2 to pi over 2, including negative pi over 2 and pi over 2. If you look at this function still continues to pass the vertical line test, and it now, right, it also pass the horizontal line test at any point. If we're looking at just where does that green line intersect the blue, okay, it would only be only at one point, excuse me. So it would pass the horizontal line test and the vertical line test, okay? So let's continue this. So So we're going to restrict the domain on sine of x. So the graph of sine of x, where the domain, okay, I'm filling in the blanks here, is negative pi over 2 to pi over 2. And the range is still negative 1 to 1, so I don't lose any values in my range, is shown below. So there's just basically the section of the graph. Now, if I take the inverse of that function, its inverse would also be a function. So what would the inverse of this sine function look like is the question. So remember, inverses are reflected over the line y equals x. So I'm actually going to draw the line y equals x there. And I'm going to graph, let's do this in red. I'll do sine of x in red. I know the point sine of x has 0, 0 on it. I also know sine of x has pi over 2, right? Pi over 2, comma 1. I also know it has the point negative pi over 2, negative 1. So the graph, as we know from above, looks something like that. That's sine of x. So what would inverse sine of x look like? Well, I know, right, again, let me make these points a little better for sine of x. I do know that in an inverse function, the x and y values are just swapped. So let's start with 0, 0. On inverse sine of x, I would also have the point 0, 0. Pi over 2, comma 1 would become 1, comma pi over 2. That would be 1, comma pi over 2. And then the point negative pi over 2, negative 1 would become negative 1, negative pi over 2. And all the other points in between, okay, would also be have their x values and y values swapped. So what would the graph of this look like? Now, I didn't do the perfect job, but those sort of look like, not sort of, they should look like they're reflective of the line y equals x. I did the best job I could there on that. But now, if I give you an input, right, like we saw before, like inverse sine of negative 1, what would the graph of the inverse sine of x tell you the output must be? Well, I would be looking at this point down here. That would give me a value of negative pi over 2. Right, so by restricting the domain of sine of x, it allows me to find values of the inverse sine of x. So let's kind of wrap this up. The domain of inverse sine of x, okay, look at the domain of the graph. We go from negative 1 to 1. Again, that is also the range, right? I'm just going to write this out. It's the range of sine of x, right? And then the range of inverse sine of x is negative pi over 2 to pi over 2. Okay. So just notice how they've swapped now. Okay. So that's kind of the basis for your inverse sine of x function. It can be a little bit tricky. Okay, a little bit tricky. So I have just a couple homework questions for you. I'm not going to go too crazy here with this stuff, but I have 2 questions for you. And here's the first question. And you can just kind of draw this out on your own. Question 1, what would, let's think about this. What would inverse sine of root 2 over 2b? So answer me that. And then the second one I would ask for is what would, actually I'm going to give you 3. Sine of inverse sine of pi over 2. And then the last one, sine of inverse sine. Let's see if I can have a good one here. Let's do 3 pi over 4. Okay, so those are your 3 homework questions I just want you to answer. Inverse sine of root 2 over 2. Sine of inverse sine of pi over 2. That needs an extra parentheses, that's just that one. And sine of inverse sine of 3 pi over 4. Try to answer me those 3 questions, okay? And we'll see how you guys did on all of them.